Every AOSP checkout starts as a blank slate. But how do you add the secret sauce for your specific hardware? Here is what actually happens under the hood. The default manifest you get from Google, as you can see highlighted, describes the pure generic Android code. It has no idea about your company's proprietary camera driver or custom applications. And that's by design. This separation is the key to building a maintainable, product-specific version of Android. Now, your first instinct might be to just edit that main file, but that leads to disaster. So, what happens if you just add your private repository directly into Google's manifest file? The next time you run repo sync, your changes will be completely wiped out. Most people trip over this because they treat the manifest like their own config file. Notice the highlighted text, it's a strong warning. The correct approach, the one we designed the repo tool to handle, is to use what we call local manifests. This lets you layer your changes on top of AOSP without ever touching the original files. This is how you avoid your work being overwritten. If you can't touch the main manifest, how does the system find your custom changes? The repo tool was specifically engineered to look for a special hidden directory. As the highlighted text shows, it's .repo/local manifests. During a repo sync, the tool first parses Google's default.xml, and then it automatically scans this local directory for any .xml files and merges them in memory. This creates a final unified manifest that includes both Google's code and your own private editions. This simple file-based discovery is what makes the whole system so robust. A common question I get from new engineers is about naming conventions. The truth is, the system doesn't care. Look at the highlighted line. You can name your file mydevice.xml, proprietary.xml, or as the custom ROM community often does, roomservice.xml. As long as it's inside .repo/local manifests and ends with the .xml extension, repo will find it and process it. This flexibility allows you to organize your local editions into logical files. For example, one for hardware drivers and another for custom apps. This organizational freedom is crucial for complex projects.
So what's the most common reason to create a local manifest? It's for exactly what you see highlighted. To add a completely new repository that isn't part of the public AOSP. Imagine you have proprietary hardware abstraction layers or else sitting in your company's private GitHub organization. Google servers don't know about them and they never should. Your local manifest is the bridge that tells the repo tool where to find these private projects and where to place them within the AOSP source tree. Let's look at the exact syntax for doing that. Here's what actually happens under the hood when you write a local manifest. Notice the highlighted code. First, you define a new tag. This is essentially a nickname for your private server's URL. Then, in the tag, you specify three critical things. The path where the code should live in your AOSP tree, the name of the repository on your server, and which remote nickname to use for fetching. This tiny XML snippet is a powerful instruction that seamlessly integrates your code with Google's. This is the fundamental building block of any custom Android device. So what's the result when you finally run repo sync? It's a two-step dance that happens automatically. First, repo connects to Google servers and downloads the entire standard AOSP source tree. Then, it reads your local manifest and, as you see highlighted, connects to your private remote, like your GitHub, to download your custom device tree. It places it exactly in the device/mycompany/myboard folder you specified. To the build system, it looks like one seamless source tree, even though it came from two completely different places. But adding code is only half the story. Adding new projects is easy, but what if you need to change something fundamental in AOSP itself? This is where the real power comes in. Sometimes you need to, as the highlighted text says, fundamentally alter a core component. Perhaps you have an optimized Bluetooth stack or a custom telephony service. You want to replace Google's version with your own, but you need to do it cleanly without creating a messy fork of the entire platform. The local manifest has a special mechanism just for this scenario. Here is the trick that took me 3 years to learn and perfect. To replace a core AOSP project, you use two tags in sequence. First, as you can see highlighted, you use the remove project tag. You give it the exact name of the Google project you want to ignore, like platform/system/BT. This tells Repo, do not download this project from Google servers. Then, right after, you add your own tag to inject your replacement. This is the surgical precision that keeps your custom builds clean. By combining remove project with a standard project definition, you achieve a clean override. Look at the highlighted code here. After removing Google's Bluetooth stack, we immediately add our own project, pointing it to the exact same path, system/BT. This ensures our custom fork maintained on our private server takes its place. This is why we designed it this way. It allows your team to manage your core modifications in your own Git repository with your own branches and history completely separate from the upstream AOSP. This is critical for long-term maintenance. Now, let's talk about where this technique becomes absolutely essential. Notice the heading on screen, use cases in device bring up. When a team at Google or in the custom ROM community starts work on a brand new phone, they don't email zip files of drivers around. The entire set of required proprietary binaries, kernel sources, and device configurations are defined in a set of local manifests. This is the blueprint for the device. This is how you can replicate a complex device-specific source tree with a single command. Imagine this. You're a new engineer on a device team. How do you get the code for the new phone? It's incredibly simple. You are given one or more XML files. You drop them into .repo/local manifests and you type repo sync. As the highlighted text explains, the tool then pulls down thousands of AOSP repos from Google, alongside the exact proprietary drivers from your company's servers needed to make the hardware boot. This one-step process is what makes large-scale Android platform development manageable.
So, how do you get started? It's just two simple shell commands. Most people trip over this because they forget that .repo directory is hidden. First, as you can see highlighted, you run mkdir -p .repo/local manifestations. The -p is important. It creates the parent directory if it doesn't exist. Then you simply open a new file with your favorite editor, like Nano. From there, you can paste in the XML definitions to pull in your custom code. This is the very first step to building your own version of Android.
Enjoyed the video? Hit like and subscribe for your regular dose of AOSP customization. Thanks for watching. See you in the next one.